This video is about LED lighting. My name is William Yan.
And I'm Michelle Su.
LEDs are in part of our everyday lives. Today we'll talk about LED lighting, mainly to replace the lighting we use in our daily life. We'll present the technical aspects of LEDs, challenges and benefits, advancements, market trends, and applications.
LED, short for light emitting diode, is a semiconductor diode where light is released when electron and holes recombine in the depletion region. Since light is emitted from a piece of solid matter, LED lighting is a type of solid-state lighting. High-power LEDs require higher power and currents for area illumination. The LED chip is mounted on a heat sink, which is used for heat dissipation from the LED, and enclosed within the lens. A few terminologies before we proceed. Color rendering index is a scale from 0 to 100 of how well a light source renders colors, generally relative to an incandescent light bulb, which has a CRI near 100. Luminous efficacy is a measure of energy efficiency of light in lumens per watt. It is the amount of light produced for every watt of electricity consumed. And color temperature refers to the light's relative color appearance, describing if the light appears more yellow or bluish in color. It is also measured in Kelvin. There are two methods to create white light with LEDs. The first is to combine red, blue, and green LED light. This method allows greater color flexibility for varying shades of white light, but the different color LEDs respond differently depending to temperature and current, which results in higher control costs for color consistency. This method is often used for custom architectural lighting. The other method is to use a blue or near ultraviolet chip, such as a blue LED, and coat it with yellow phosphor to produce white light. This approach allows high volume manufacturing, which lowers costs and higher efficacy, but the resulting light from blue and yellow is at a higher color temperature, which is cool or bluish in color. This is the interior of one LED light bulb from Cree. An array of high-power LEDs is mounted on a circuit board, which is used for programming control settings such as dimmable lighting and color correction, and maintain the appropriate voltage and current for the LED. There's also another heat sink used to dissipate the heat from the array of LEDs. LEDs can be dimmed by running at lower currents or with pulse width modulation. This is possible because the human eye can't detect high-frequency light pulses and averages the light intensity to perceive dim light. One of the challenges of LEDs is the need for proper thermal management. The lack of thermal management will result in color shifts and diminished light output in the short term. Color shifts occurs because LEDs have a varying light output due to changes in junction temperature, which is affected by the current, ambient temperature, and how the LED is designed to dissipate heat. Amber is the most sensitive to temperature, while blue LEDs are the least sensitive. The changes in light output from each color could result in imbalances of colors. Continuous operation at high temperatures will result in accelerated lumen depreciation, which will reduce the operating life of the LED lamp. Useful life is the hours before the LED outputs 70% of initial lumens, which is when the human eye starts to notice changes in the light output. In this graph, the useful life on the LED at 74 degrees Celsius has a 57% lower useful life than the LED at 63 degrees Celsius.
So how come not every household have replaced their incandescent CFLs with LEDs? Other benefits of LEDs do come with a cost. The average price of an LED is about 46% more than the average price of an incandescent light bulb. However, the total cost of an LED is in fact cheaper than incandescent, but not as much difference from CFLs. This indicates that the savings from using energy-efficient lighting will be greater in cities with higher electricity rates, such as New York and San Francisco. Consumers are often faced with the upfront cost. Considering both has high energy savings, which light bulb are you willing to purchase? Despite these challenges, many investors and governments around the world are looking into LED lighting to meet the trend of becoming more energy efficient. So why LEDs? LEDs are proven to be energy efficient and provide energy reduction costs in lighting compared to other traditional lighting technologies. LEDs are approaching the 100 lumens per watt level. Already today, many of the traditional lighting technologies have been replaced with LEDs in a wide variety of applications. For directional lighting applications, LED could have higher efficiency. Since incandescent lamps and CFLs shed light omnidirectionally, some of the light will be redirected towards the fixture and absorbed by the lamp, resulting in wasted energy and higher temperatures to maintain. The LED operating life lasts at least 35 times longer than incandescent light bulbs. As mentioned before, the actual operating life of an LED depends on the junction temperature. Majority of CFLs contain about 4 to 5 milligrams of toxic mercury and creates disposing an environmental challenge. LED light bulbs do not contain toxic materials and last much longer than incandescent and CFL light bulbs. Many of the LED fixtures are made from aluminum and can be recycled. CFLs are not designed to turn off and on quickly. They require a long startup time to reach the best operating light output, whereas LEDs turn on instantly with constant brightness.
So overall, to compare, incandescents have low efficacy and lifetime, but high color temperature and CRI. CFLs have higher efficacy, longer lifetime, but lower CRI. LEDs with high efficacy have higher color temperatures, so they are called cool white LEDs. LEDs with warmer color temperatures generally have lower efficacy and are called warm white LEDs. LEDs also have significantly longer lifetime. LED technology is also constantly improving. Research is being conducted using quantum dots, which are nanometer-sized semiconductor material that fluoresces when excited by photons or electrons. A company, QD Vision, produced an optic coated with a thin film of quantum dots fitted over a blue LED lamp. The lamp produced light that maintains its high efficacy in CRI but at warmer temperatures. Now we will talk about LEDs in the market and lighting trends. Despite the emergence of energy-efficient lighting like CFLs and LEDs, incandescent lighting still account for around 1.5 billion lamps per year. In 2007, a survey showed that of the 24.2 bulbs used in a Canadian household, almost half was using incandescent bulbs. Thus, countries are starting to implement regulations to phase out the incandescent light bulbs. In Canada, this will begin in 2012 by placing minimum lighting requirements to be met. In Europe, the phase-out initially led to periods of incandescent bulb hoarding, but recent figures showed increases in CFL sales.
Let's look at the current overall lighting market. The size of the lighting market is estimated to be $90 billion. LED lighting have a 4% market share in the overall lighting market. Analysts predict a compound annual growth rate of at least 30% in the next 5 years. So what trends will be driving this growth? Currently, the largest driving force of LED fixtures are from consumer portable applications. Residential lighting is expected to be the fastest growing segment of the market in the next 5 years. The commercial industry segments are also attractive to generate revenue of $1 billion. Outdoor area lighting like street lights and traffic lights are expected to grow at a CAGR of 38%. So who are the big players driving these trends? Analysts predict that China is the largest market for and as well as the largest supplier of LED lighting. China, Russia, and India have about a 40% increase in demand. With the trend increasing at a quick rate, programs like Energy Star have already initiated guidelines for testing the quality of LED light bulbs. Besides consumer confidence, government and regulatory bodies are involved with energy-efficient products. With the regulation of quality and guidelines for buildings, LEDs are attractive to replace traditional lighting technology. BC Hydro believes that 5 to 20% of total household energy used is from lighting. LED lighting can be a significant contribution of obtaining LEED certification for a new building or building remodeling. The optimization of energy performance is worth about 1 to 10 points in the LEED certification for new construction and renovation of buildings. One example is a 5-story parking garage from the University of Nebraska, which attained the USG BC LEED certification. This was largely due to the implementation of new LED fixtures.
Another potential application for LEDs is in street lighting, which has been dominated by metal halide and high-pressure sodium lighting in the past. The low energy usage and long lifetime of LEDs are suitable for street lights and could lower the frequency of maintenance, but is relatively more expensive to implement. Thank you for listening to our presentation.